All right, so now I'm going to look at number 24 on page 441. It just says draw a graph. Now you could totally do this, but I just want to say a couple of things about the graph. So one thing, by the way, is on your graphing calculator, you have sequences as a mode. So if I go mode, and so we've used function, we've used parametric, we've used polar. Here's sequences. So I hit sequence, right? So then I go to my y sub n, and oh look, I've got this. I can't even. I don't know what that says. U sub n, I guess, or is that there's like a U sub n and a V sub n? That's pretty weird. Did not expect that. Anyway, it probably works pretty much just like A sub n. Is it just me or is there a U and a V? Yeah, I guess you can. I guess like U is one sequence and V is the other one, and then there's a W. Oh, you can only graph 3 sequences, and they're called U, V, and W. Okay. And then n min is 1 because n always starts at 1. Some people will sometimes start the n at 0. It's, you essentially are redefining what a sequence is, but that you can do that. All right, so I'm going to put in my n minus 2 over n plus 2. So n, see, it comes out n minus 2. So you play around with this. It's fun to just know that there's one more thing your calculator can do. All right, and think about the window here. So this window, it's going to be, the limit's going to be 1. So this is going to be converging to 1. So if I look at the window, probably, it already gave me my n min and x max 1 to 20. That'll probably do. Plot start, plot step. I guess that's just starting by 1, stepping by 1. My x min, it has negative 3.79 for some reason. I think I'll probably just go negative 5 to 5. Oh, that's x min. That's weird. Obviously, I've never messed around with this. Why wouldn't the x-min just be like 0 to 20 if your n-min goes from 0 to 20? Why wouldn't that be x-min and x-max? All right, and then your y-min and y-max is what I was really, let's make that be negative 5 to 5, and let's just graph it. There you go. All right, it just goes up. We could, I don't have a lot to say about that. I guess I would run this, let's say, I like negative 2 to 2 on that. And there. So it's dots. So one thing that I want to say about graphing a sequence is a sequence is not a curve. It's a bunch of dots. It is not a continuous graph. It is a discrete graph. All right. That means that the points do not connect because there is no a sub 1/2 or a sub 1/4. All right, so this graph, and you don't have to graph, it exactly. It just goes like something like that, and it'd be nice to note that the limit is 1. It goes to 1. All right, you could, by the way, and your y equals. Let's put in just for comparison, u sub n. Or I guess that's v sub n equals just 1, and then so we'll have that as a comparison. So here's 1. Here's our sequence that you can see is getting closer and closer to 1 as we go to infinity. So if we set the window up to, let's say 40, right? So our x max has to be 40. I guess I don't know why they put that separately. So you can see the sequence values approaching 1. That's pretty nifty. All right, anyway, just cool that you can do that. That's all I want you to do for number 24. All right, so I really want to look at, was that 24? Yeah. So I really want to look at 31 through 39 because those are assigned. These ones say determine the convergence or divergence of the sequence. If the sequence converges, find its limit. So these two words, convergence means the limit exists, and divergence means limit does not exist. It's just sometimes we have sort of specialized terminology for different contexts. In the context of functions, we use convergence and divergence instead of exists and does not exist. So these are so easy because you understand limits well. Number 32, we want limit as n approaches infinity of 2n over n plus 3. That's not how they said it. They said establish convergence or divergence. So they're really asking you, what is this limit? All right. Degrees are equal, so ratio of the coefficients, it's 2. That's all you have to say. Number 34, we have limit as n approaches infinity of n over n squared plus 1. Degree of the denominator is larger, limit is 0. That's all you have to say. I think 36 is interesting. So 36, we have limit as n approaches infinity of negative 1 to the n. You can sort of graph these if you want to sort of see what goes on. Negative 1 to the n times n plus 1 over n squared plus 2. All right, so if you think about what's going on, this part of the expression is going to 0, and this part of the expression is alternating signs. So if I have an expression that's alternating signs, but it's going to 0, the limit is still 0. Right? If this limit was 5, but I'm alternating signs, then I'm going to be going back and forth between 5 and negative 5, and I'm not going to have a limit. We're going to say the sequence diverges. Right? But this one, the limit is 0. All right, what about number 38? We have a limit as n approaches infinity of 0.9 to the nth power. I guess put the brackets there. So you want to recognize that this is a geometric sequence. So you can graph all of these. I would encourage you to graph all of these. But one thing we've just figured out is that for a geometric sequence, r to the n, if the absolute value of r is less than 1, it goes to 0. If the absolute value of r is greater than 1, it goes to infinity, etc. All right, so we just want to recognize that this is geometric with r is less than 1, so that limit equals 0. If you want, here's a nice place you could put a justification, because a sub n is geometric with absolute value of r equals absolute value of 0.9 is less than 1. That's the kind of justification we will be headed toward sometime in the future. Okay, now, so the last one that I want to look at here, number 40. So this says a sub n equals cosine of n pi over 2. So what am I going to do with that? So a sub n, I want to write limit as n approaches infinity of cosine of n pi over 2. So it might sort of be helpful to think about what that is doing. So, this is going to be, how's it going to go? It's going to go cosine of 1 pi over 2, then cosine of pi, then cosine of 3 pi over 2, then cosine of 2 pi. So we can sort of, and this is going to repeat the cycle, right? So cosine of pi over 2 is 0, negative 1, 0, 1, 0. So you can see what this is doing, 0, 1, 0, negative 1. So if I made a graph of it, so basically any sequence that is a sine or a cosine, is the limit's always going to not exist, because we're going to go 0, negative 1, 0, 1, 0, negative 1, 0, 1. There's never going to be a point where I can draw a small epsilon band that will contain all the points. So the points are always jumping out of any epsilon band. So this limit does not exist. This sequence diverges. Okay, that is all I have to say about sequences at this time. Your homework, as I previously indicated, is here and as will be posted elsewhere.